Hey everyone, good morning. Hope you can see my screen and I'm audible. Can someone confirm? Okay, fine. So, welcome you all to the webinar on pillars of VLSI design verification and hope you all doing well and you're all eyeing for a VLSI career, right? Hope so. The purpose of this webinar is to make you all understand what exactly needed for being a VLSI design verification engineer, right? So let's walk through the process, what exactly required to be a VLSI design verification engineer, and let's try to understand how actually the things will go in verification, what exactly verification engineer will do, what are all the mandatory things one should learn to be in the industry. That is what the purpose of this webinar is. So at the end of this webinar, you should be able to express what is the roadmap to become a design verification engineer being a fresher, right? Many of you are students and working professionals, and also those who are looking to be a design verification engineer are here. Okay, let's the session be interactive. If you have any questions in between, please let me know. Let me try to address that then and there itself. Okay, if you have anything in particular, please put it in a chat. Let's look at that at the end. So before we step into myself, I am Sujay Essen. I am a founder and CEO of Logic Cells Technologies. I am also a design verification mentor. I worked in Intel. I worked for Nokia. I worked for Capgemini. Okay. So this is a brief introduction to my journey. Now I would like to know who are all present in this webinar. What actually the status of audience today? So just comment in the chat what exactly you are. Are you a student, or a graduate, or a working professional, or you are looking to switch your career to VLSI? Okay, I'm getting so many responses here like student, recent graduate, student of 7th semester. Yes, you can mention what exactly your status is. Student of which semester? You are an professional. Yes, Sagar is a working professional, and many of you are students. Any freshers here? Completed engineering just now in 2026 or in 2025? Yes, finally a student, working professional. Good that we have some working professionals here. Let's also hear from them what exactly they say, what kind of work they do. Any VLSI professionals here who are working in the VLSI industry? Okay, many of you are in 7th semester, 4th semester. That's good. 5th semester. Yes, Madhuri Reddy, she's working in VLSI. Are you working in VLSI domain in DV?
Yeah.
Yes.
Yes.
Okay, good. Anyone else apart from Madhuri here working as a design verification engineer joined this webinar or in any other domain of VLSI? Okay, fine. Okay, now I got to know that. Now I got to know many of you are students and few of you are graduates, and it's good that many students from lower semesters, let's say 4th sem, 5th sem, and even in 2nd semester students are there here. Being a student, they will think like, can I build a career in VLSI? That is the very first question every student will get during their studies. Correct? Am I correct? Every student will get a question that, can I build a career in VLSI? Where actually I should start? Is this goal achievable? Or should I choose software domain? Similarly, as many others do, being a electronics engineer. So the very first question students think is, can I build a career in VLSI? The straightforward answer is yes, you can do it. Right? You can do it. First, we need to commit ourselves that, yes, I will do it. Okay? Then what exactly the recent graduates will think? I learned the basics during my engineering journey. I learned Verilog, I learned CMOS VLSI, I learned other analog and digital related subjects. Now, how do I get my first job in VLSI? Now, everyone is saying VLSI is good. We have a good future in VLSI. India is heading to VLSI fabrication, manufacturing. We may get more opportunities in VLSI in future, right? All these are the talks going on, right? But how do I get my first VLSI job? That is what many engineers or recent graduates think. Correct? Are you thinking in the same way if you are a graduate, recent graduate? Now, let's see what exactly working professionals think. I started in VLSI. Okay, if someone started in VLSI in their early career, can I grow without starting from scratch? Means without understanding what exactly needed to be in a VLSI domain, can I grow further? Or what exactly I need to learn in day to day, get into the next higher position? How to switch career? right? That is what working professionals think. It is not a one-day task. Every day you need to learn. Every day you need to gain knowledge. Then only you will succeed. Then there are some career switches. There are many other domain engineers in IT domain and working in embedded domain and also in automotive domain, testing domain. They will always try to switch back to core domain, right? Many of people we see they will be working in IT for any reason they choose IT at the earlier stage. After some 2 years, 3 years, they want to switch back to core. It happens. We saw these things many times, right? So is that possible? What skills I should get to be in VLSI, to get a job in VLSI, right? These are all the questions we have in each and every stage of our career. Being a student, many of you are students here, you will be having a doubt that can I build a career in VLSI? So commit today, yes, you can do it. But there is a standard way, there is a strategy, there is a standard roadmap you need to follow. If you are very random about your studies, it's very difficult to get into, right? Let's discuss all that in this webinar, and also let's try to get the confidence ourselves. So why VLSI? Why exactly many people are thinking about chip design? Why India is so much investing in chip design? What exactly going on in the world now? AI is one thing which is disturbing everyone, that how exactly I should go with along with AI. Should I learn AI first? Should I learn VLSI first? Right? What exactly going on? AI will take over the jobs, manpower will be reduced. But remember, in VLSI, it is not so easy. In VLSI, it is not so easy to replace human being. Human is required, human knowledge, intelligence is required in VLSI. It is a bit difficult to replace a human being with complete AI model, right? Why? Because every AI model runs on chips. Ultimately, a chip designer, verification engineer, fabrication engineer required, but not the same case in software domain. It can be well automated with AIs now. A complete website can be built, right? Do you guys know that? We have enormous AI models today, AI agents today. A website and web application can be designed in a minute, right? But it is not the case in VLSI. If you want to bring up a chip from starting from the specification stage to the chip, it will take minimum 2 to 3 years if it is a very simple ASIC, right? So even remember, AI work on multiple complex, right? Every AI model runs on chips today. So even AI advances, our chip requirement increases. Then coming to the automotive domain, you can see many smart vehicles are coming out. Everyone buying electric vehicles. Even each and every automobile become very automatic today, right? There are many sensors, many automation has come in automotive industry as well. So the reason is electronics behind it, and also majorly chips. Again, consumer electronics is one of the fast growing field. Every smart devices depends on silicon chip. Again, your smartphones, laptops, handheld devices, home automation, all these comes under consumer electronics, depends on smart device. Again, a underlayer is silicon, right? Then cloud computing, every one of the applications which run in cloud again depends on some chip which is supporting that. Then 5G networking and data. So all that high speed access what we are getting today because of the powerful chips. So the reason behind every advancement is VLSI. That is why everyone saying semiconductor is booming, right? Not only in India, everywhere. And also in medical devices. If you go to hospital today, they will check you with some equipment. They will not check manually now. Correct? Can you agree? There are many things, advancements happened in field as well, and that again depends on the chips. So these are the different sectors. These are the different sectors where actually we can see the advancement in VLSI in real time. Right? Now the reality. Why are EC students still struggling to get into VLSI? Let's understand in a perspective of a student. He is in seventh semester, he is in final years, who is attending placements, and some of them are even looking at companies for internships. What exactly they do in their journey? In colleges, they will gain digital design. They will understand how combinational circuits, sequential circuits, what is Boolean algebra, why actually gates are required. All that foundation they will get. Then they will understand what is the transistor level circuits for that, how MOSFETs work, how CMOS circuit will be written, what is schematic, what is layout, how the fabrication will be done, what do you mean by a silicon chip. Everything they will learn in a basic level in CMOS VLSI. And the next thing is they learn Verilog HDL, right? Everyone here, many of you are students. Can you agree you will learn Verilog in your academics? Correct? You will learn Verilog. But there are some advanced languages required to be in VLSI. Now, no one is studying VHDL, but still in some companies, the design is made using VHDL, right? There are some legacy projects. There are some defense and related, aerospace related. Some projects are still going on in VHDL. Even with VHDL knowledge, you can try to get into the domain, right? Science person can learn VLSI courses. Yes, exactly. Any science person, not only engineers, even MSc physics, MSc chemistry, even some others who are in physics related subjects, any science domain candidates can get into VLSI today. Okay, but the thing is, what industry really require is, can someone uh, able to handle the chip design, verification, physical design things. They will not check what exactly you learned in college, but they will check what exactly you will perform if you get a job. Right? Yes, Muhammad Ibrahim pursuing Verilog language. Yes, fine. So Verilog is one common language everyone study in electronics, even in electronics and any other related domains. But I have a question here. Can computer science guys come into VLSI and sustain? Can anyone answer? Just put a comment. Can computer science guy, if he is interested in a VLSI domain, can he get into VLSI and sustain? Yes, that is what I mean to say. See, even in computer science, you will learn microprocessor, microcontrollers, computer architecture, networking subjects, right? All that again being a part of this ecosystem, right? But the thing is, C language, you may know OOPS. You need to tune that into a hardware level. You need to think as a hardware engineer once you get into VLSI. Nowhere you need to compare with a software roles. It is not like a developer role. Even if you are a design engineer here, you are writing a Verilog code, you are not writing a software program. Please don't call it as a programming language. It is a coding language. You will write a single line of code for a particular hardware, right? That is how VLSI works. So after Verilog HDL, you might have studied computer architecture in your academics. Okay, that is very good. You will be understanding system level perspective. What exactly a computer can do, what exactly the different parts of the computer, and how exactly pipelining works. All that you will understand in computer architecture. So that is very much important as along with CMOS VLSI, digital design, Verilog HDL. But there is a gap here, right? Everyone should understand. The gap is not your knowledge, it's a practical application and industry readiness what is required. That is exactly the gap you will face in colleges. Many colleges adopting these industry related things now. They are having tools, they are bringing industries for some workshops, they will be preparing the students for their core jobs. That is very good. But many colleges lagging in industry readiness, right? So you will come out of the college as a electronics engineer, but you will struggle to understand what exactly required for industry. Correct? That is what happens with many of you. So now we are concentrating on a particular domain in VLSI, that is VLSI design verification. I will also try to talk about other domains in VLSI if you want. But since the purpose of this webinar is to understand what exactly required for a VLSI design verification engineer. Okay. Let us have a response quickly. What are all the different domains we have in VLSI? What are all the different domains you have in VLSI in industry? Can anyone quickly comment if you know? One domain is shown here. VLSI design verification engineer is one role. RTL engineering, yes. RTL designer is the very first role you can say, being a design engineer. Physical design, yes, that will be called as back end. Yes, correct. Design verification, yes, that is what functional verification or ASIC verification engineer, FPGA verification engineer are. Analog design, yes, you will write a schematic and layout related to analog chips, that is analog engineer. Yes, design verification. Yes, any other answers? Anyone know? Yes, floor planning, testing. There is nothing like testing engineer in VLSI. We call it as validation engineers. So in validation, we will be sitting with a silicon exactly, means a chip which coming out of the foundry, and we'll validate it. FPGA engineering, yes. Okay, remember there is nothing called test engineer here. Testing will be done after the fabrication and the packaging is done. That we can just call it as a test engineer, which is not coming under VLSI. Okay, fabrication. Yes, great. See, majorly we have design engineer role, then verification engineer role, Then DFT will come in between. Okay, yes, Dharani is telling DFT. DFT will come in between. Then physical design. Okay, after physical design, there are many other small roles in between. Timing analysis. Someone may work only on the some part of the synthesis. Okay, and someone may be VLSI architect. There are different roles, but majorly you can categorize as design, verification, and analog layout, and physical layout. Okay, physical verification. So these are the different major domains in VLSI. Okay, being a fresher, okay, it is good to concentrate VLSI design, verification, and physical design. These are the two major domains which take freshers. Okay, you can be a VLSI design engineer, RTL design engineer as well, but there are very less opportunities for freshers. Why? Because companies look at their own engineers who are good at design, and they will take the design verification engineers as RTL design engineers or other domain engineers into design stage. It means you need some more experience to be a designer. Okay, so design verification is the one stage where freshers can easily look at. And most students learn, as I said, digital design, CMOS VLSI, Verilog, computer architecture. And without knowing the advanced concepts, if they start applying for jobs, there are very less opportunities you will get. Okay, means there are less chances of getting into interviews at least. For being a VLSI design verification engineer, you need system Verilog. Okay, you need UVM. You need protocols. There are some standard protocols you should learn. In any of the project you go and work in an industry, that will be having protocols. Chips communicates through protocols. Then debugging knowledge is very much required. Then real projects you need to work on protocols. And tool knowledge. Okay, tool knowledge mean you need to understand what exactly the EDA tool required for a particular role, right? So there is a question here: openings are available only in design? No, Mohammed Ibrahim, there are very less opportunities in design side. If you see a fresher verification opportunities, you can see few of them. But if you check for RTL designer role, there are very less opportunities. Why? Because remember this: if there are 10 people in a project, okay, usually there will be more people, but let's assume there are 10 people. Two people will be working on design part. Okay, let's assume it like that. And more than two, let's say some 5 to 6 people or 4 to 5 people will be working on verification, and the backend team will be having 2 to 3 guys again, and maybe one guy working on DFT or for some temporary purpose. And at the end, during the tape out stage, 1 or 2 guys will be working. Most of the time of a chip design cycle spent on design verification, and design verification will be consuming 60 to 70% of the time. So more engineers are required in verification stage. Remember this. Okay, and tools like Synopsys, Cadence, and Siemens and Vivado, yes, they are required, right? So design verification stage takes much time in design cycle. That's why here more engineers are required. You will find some opportunities here easily compared to any other domains. Okay, let's move on. So here we have seen these are the different things required, but we talked about very four important pillars, right? We started from there, correct? The very first pillar is Verilog, next system Verilog, then UVM, then what exactly is this protocol? How many of you say it is protocol? If you know some background of VLSI design verification, please let me know. What is the fourth pillar? Is it protocol or debugging knowledge or a real project experience or the tool knowledge or scripting? Quickly comment what do you think as a fourth pillar? Real project experience, okay? Real project experience, tool knowledge, protocol. Okay, let's understand what exactly needed for being a VLSI verification engineer next. But before that, I just want to hear from you, in your perspective, what would be the fourth pillar here after learning Verilog, system Verilog, and UVM? Okay, what exactly needed? Scripting, protocol, scripting, debugging, tool knowledge. Yes, real project experience. Yes, all these are required. Okay, all these are required. But the major fourth pillar here is maybe any one of these. Let us uh, look at it. Look at this. So the very first pillar is Verilog, right? Why exactly that is a very first pillar? See, without uh, knowing anything about VLSI, okay, what people think, without being a VLSI engineer or without being an electronics engineer, he don't know anything about the electronics. So for any other guy, what exactly VLSI is? Finally, a chip, some hardware, right? Correct? Do you agree? Without being any knowledge of coding, how actually things work in VLSI, for any other random guy, it is a chip. Finally, it is a hardware, right? So remember, you are writing some Verilog code mean you are designing some hardware. Exactly. Verilog is not a programming language, I said at the starting, right? It is a coding language. You are writing a code for a particular hardware. If you write a single line of code that reflects a hardware, that is what your Verilog design is, right? So while reading or learning Verilog, please think of it like I am writing a hardware. I am putting one block. Okay, I am putting a flip flop here. I am using an AND gate here. This is an adder. This might be some parallel process. It will take a flip flop. It will take a multiplexer. Likewise, you need to think and write Verilog. Okay, so RTL is the foundation of every digital chip. Okay, and you need to think of a hardware and then you need to write a Verilog code. That is how Verilog works. And why actually we need to write a such code? Why we need Verilog? Can't we directly go and connect some circuits using logic gates, what we learned in our academics? Can we do that? No. Though, so the system is very complex. We can't go into a lower level and build it from the scratch using components directly, right? We need to know the behavior of that, write it as a code, let tool convert that into a hardware. That is what we do in a Verilog design stage. Okay, so it is not just a syntax; it is a real hardware what we are going to get at the end. That's why this is the very first pillar. Everyone being in a digital domain has to understand Verilog. Okay, then a very next thing here we need to concentrate on system Verilog. System Verilog is again a coding language. Okay, it is an improved version of Verilog, we can say. System Verilog is class based, added with OOPS features, object oriented programming features. Okay, here we will be writing a test bench. The complete verification will be done using a System Verilog test bench. This System Verilog built upon Verilog only. If you know Verilog, already you know some 20-30% of your verification. You mean um, knowing a Verilog, you can write a design code. Okay, you can write a test bench as well, but Verilog test bench is not sufficient to verify the complete functionality of your design. As I said, complex designs require complex test benches as well. Correct? Simply, we can't go and write a 10 line of Verilog code giving some standard hard coded values, and if you come up with the result that the verification is done, no, it will not work like that. Verification is a very important stage at which your complete hardware, what it will come out after the fabrication, it will function, will be checked in the simulation stage. Okay, that's why OOPS switches are required here. Test bench is written using dynamic class based components that supports object oriented programming. Then I talked about the data what we are going to provide through the test bench. If you give it manually hard coded values, that is not sufficient. If you are just checking a simple gadget by some small features, when you are using some hard features, it may not support, it may not work properly, right? So we need to provide some random data. We need to constrain that random data what the tool is going to generate, and we need to verify our design. Okay, that is why constrained random verification is required. That will be supported by system Verilog. This is not the feature of Verilog. Remember this. This is the very first difference you can make out easily. Your Verilog will not support OOPS. System Verilog support OOPS, means object-oriented programming. Your Verilog will not support constrained random verification, but system Verilog supports. That's why we need system Verilog for verification. Then coverage. See, after some test cases, after verifying your design, you will be getting a metric that how much part of your design is covered through the verification. You might have written some 10 test cases, 20 test cases, and you might have covered all the functionalities of your design. But if in case a corner case is missing, your coverage will give you the result that, hey, you have covered only 90% of your design. Some 10% of the functionality is not at all verified. Go back and write a test case. That is what coverage is. Even this is not supported by Verilog. That's why we need system Verilog here. Then the third pillar is UVM. Do you think UVM is a new language we need to learn? Can someone answer? Do we need UVM as a new language to learn? We already learned Verilog, we learned system Verilog. Again, do we need one more language? No. It's a methodology. Yes. Some of you are answering correctly. Yes. It is not a new language or a coding language we need to learn. It is a methodology built on system Verilog. Okay. If you know system Verilog test bench, you can easily adopt UVM methodology into that. And you can learn UVM easily if you know system Verilog concepts. Okay. That's why we can't directly jump into UVM here. What verification strategy that will be followed in industry? You need to learn system Verilog. System Verilog is the base for UVM. But what exactly UVM is? How it differs from system Verilog? UVM will be having a base classes. It is a structured way to develop your test bench. Already, what are all the required things for verification is already done or developed in a base classes. You can use these base classes and you can directly put your effort in improvising that or adapting that into your particular design verification. Okay, that is what the advantage of UVM is. It is already having base classes. Structured way to develop a test bench is already built. You can use that and you can improvise on that. That is what UVM is. It has a standard method to build and run the test bench. Your simulation will not directly kickstart and give you the result. It will go through each and every different phases. That is adapted in UVM. It is not there in a simple system Verilog level. So UVM is required. And then reusability. If you write a test bench, if you write a test bench for a particular project, that can be reusable or that can be reused to any other project. It should be easily portable. That is what it means, reusability. So you need to write a code in UVM in such a way that it should be reusable, it should be scalable to any other level, and you should follow a standard structure what all other industry people use. Then only they will believe your verification method, right? Otherwise, if someone designs and someone verifies and someone fabricates, how do they believe whether you have verified and designed properly? So there should be a standard approach which everyone follows, right? That's why it is a standard approach. A universal verification methodology mean every industry people or everyone adopted the same principle of verification. That is what UVM provides you. Okay. Okay. So remember why we need to go for UVM mean it has a base classes architecture already. We can use that and then we can adopt easily into a standard method what everyone follows, right? That's why UVM is required. It has enormous automated features. No need to write the code from scratch. You can start adding the lines in between so that you will be building your own test bench for the design what you are verifying. Okay, that is what exactly UVM mean. Then let's move on to the fourth pillar, what we are really excited about, right? So after Verilog, System Verilog and UVM, okay, many of you said scripting is the fourth pillar we need to concentrate on. Many of you said tools, protocols, and projects, right? So after UVM, you should understand protocols. Remember, after UVM, you should start understanding protocols. Even after System Verilog understanding, to be a VLSI design verification engineer, you need to understand protocols. Why protocols are required? See, if you want to communicate with someone, we will use some language, right? I am using English now. You all can comfortably understand. So we have some protocol in English that if I talk in some way, you will easily understand, right? That is the protocol. If I ask you to comment here, you will understand I need to type it in a comment box and I need to put some message, something like this. So we both know ourselves that this is the standard which is followed in English, so we can communicate. In the similar way, inside a chip or inside a hardware system, if two chips want to communicate or two systems want to communicate, they need some common protocol. They can't communicate in English, correct? They need some binary values finally. But how actually that binary value need to be communicated from one component to other component is a protocol. Okay, your protocol builds the communication. It will set clear cut rules and a data formatting and a timing and a handshaking between the two components inside a chip. That is what exactly protocol mean. Protocol is not something like a new thing which was introduced today. Protocol is there from very long back. We people are communicating each other with a protocol, right? There are some protocols set by your colleges. You need to communicate to your teacher in this way. You should not do these things. You should do these things. You should come at 9 o'clock. You should go at 4 o'clock. These are the two timings, right? Similarly, your chips will understand timing. So you see, suppose if you take a very simple scenario where there is a memory, okay, RAM. You need to provide the information that whether you are doing a write operation or read operation from the memory, whether you are loading the data into memory or you are extracting the data out of the memory, right? That is the protocol. If you give a command like write, then your system will understand, hey, someone is writing on me, I need to be ready to get the address, get the data, and let me consume it. If he is doing the read operation, I should be ready to understand the address and give back the data. So if you think of a simple protocol in a memory, it has two stages. First, give the command, it will understand. Then give the data if you want to write, or give the address if you want to read. This is what exactly protocol is. So many systems what we have today are sequential circuits. If you know sequential circuits, you will understand a clock. It comes with a timing, and you will send the data along with the clock edge. That itself a protocol mean. Okay, you need to give the data in a particular time. You need to follow the protocol that you should give this much first, you should give this much first, you should give this much next, like that. So it give interoperability, means IP blocks from different vendors can work together seamlessly. See, all the chip components what we are using today in our systems will not be built by a single vendor, right? Micron build memories, Qualcomm build processors, Intel build processors, Marvell build some control units. So what? So there are many different companies build different IP blocks. If you are bringing them together into a single chip, you need some interoperability, right? They should work together. They should understand a simple protocol that, oh, this guy will understand the data in this manner. Okay, so you need a start bit, you need an end bit, you need data in between, you need a parity bit. These are some standard formats you have learned in your academics, right? That is exactly a protocol mean. Okay, then manages complexity. See, when it is very complex scenario, if you want to make them, let's say, the system understand, you need to go with a standard method, right? You need to have a standard system, right? So which will divide the massive system on chip designs into manageable interfaces. There are different interfaces, right? So it is just like in your college, you will be having different departments. If someone has to go to computer science department, he will enter into computer science building. That is what interface mean. If some signal has to go to a particular memory, it should enter into a particular interface. So if you want to plug in a let's say a memory card, you need to plug into a memory card slot. That is what a memory card reader interface will be there. That is what manages the complexity if you have protocols. So to be an verification engineer or a design engineer or any other engineer in VLSI, you need these protocols. This is your fourth pillar you need to concentrate on. Okay. Then what exactly the next thing? Debugging. After understanding the protocol, you should build some project out of that. You need to design and verify. So where exactly the verification happens in debugging? What exactly the major role of a verification engineer? Can anyone tell me? What exactly the major work of a verification engineer? Can you comment now? What is the major role a verification engineer plays? Verification, functional verification, functionality checking. Yes, but debugging is the very main aspect of a verification engineer. He has to debug if something fails. He has to find out why exactly that mistake or the issue is in a design. Waveform checking. Okay. Verifying the RTL design. Correct. But where actually your debugging matters here? In which stage? See, first you will write a test bench. Your test bench will give just a standard approach to give you the data to design, and design will respond back. You may get some issue there. A unexpected behavior. Your data is not going properly. If your design is not expecting as per the functionality, that is your issue. That is your issue. You will identify an issue. Okay. Let's say a very simple example. Let's say adder. Your adder is not giving the actual results. If you give 1 plus 2, it is not giving 3. It is giving 4, let's say. That is an issue. But you need to debug where actually the mistake is in design. Correct? That is what the exact verification is. You can't simply go, this design is not working fine. Hey designer, go and fix it. 1 plus 2 is not 3, it is giving 4. No, it will not work like that in industry. You should find where exactly the mistake is. Not exactly the particular line where the designer has made a mistake, but you should indicate which are all the particular values it is giving the wrong result and where actually it is failing. Which part of the design is failing, something like that. That is exactly debugging mean. So real verification happens here. Companies love debuggers. Remember, if you are attending interviews tomorrow, you need to mention what is the debugging you did in your project. What is the error you find out? If there is some issue in the design, how you debugged. If you put this in your resume get highlighted. There are high chances of getting into interviews. Okay, everyone will put protocols, everyone will put projects, but they will fail to highlight how he did the project, whether he debugged some real issue. Okay, whether he know how to debug. These are the common questions everyone will ask in the interview, at least in the second level of the interview. Okay, so in the very first level, they will check your knowledge. If you know knowledge, if you have knowledge, then they will check how exactly you did those projects. That's why projects are very important in your resume. Correct? You have to put the protocols, you have to put the projects, what you have done. But similarly, you need to make them understand you debug the real scenario. Okay. Then it's very easy to get into industry through your skills. So then what exactly needed after the debugging stage? You learn debugging, then you need to do projects. Through projects only the debugging happens. Otherwise, see, I will give you another strategy here. See, many people ask, sir, how actually I can learn debugging? Debugging is not a protocol. It is not like a protocol. It is not like a coding language. It is not exactly a waveform analysis. What exactly debugging is? How actually I will learn debugging? See, if you start writing a code, many tools what we have today will give you the error then and there itself. Correct? It will indicate the error in red mark, or at least after the compilation is done, it will show some errors. Correct? You need to understand why exactly that error is coming. That is from where you will start debugging your code. You need to read the complete line of that error and understand, oh, this is missing. I have coded in this manner, that's why I'm getting this result. Okay, you need to put more print statements or more comments into your code so that you will get a proper log in your uh, uh, log, right? After the simulation, you will get a log. In that log, if you get more prints, what exactly happening in each and every stage of your verification, then you will come to know where exactly I am going wrong, right? So you need to know how to understand that particular issue error is. That is the first thing. The next thing is after the compilation, you will get a log. Through the log, you will understand what is going on in my code, and then you will try to address that each and every problem. That is how debugging will be learned. Directly doing the project, the mistakes present inside a design, identifying that, and then that is a debug. No, you need to start debugging from each and every line of the code what you are going to write. Make mistakes, learn the debugging. Make mistakes, learn debugging. This is what the only way to learn debugging. Okay. So there are some questions here. I think let's address that quickly. Some people are trying to join now. Okay. Okay. So that is how you need to learn debugging. Debugging is not a thing which can learn in one overnight. It will come through practice. So that's why, yeah, AI as a fresher, can I use AI tools for code writing? Yes, you can use, but carefully you need to use. That the code what your AI will give depend on the prompt what you are going to provide. Okay. Just if you ask something like, hey ChatGPT, can you provide me the code for ALU? It will give its own code, but you need to understand why that is ALU, what is the size of that ALU, what are all the features you need. So you need to be very careful while using AI tools. Okay. Why? Because you may be in a right path, learning through these coding manually. If you adapt into AI, let's say I use ChatGPT for generating the codes, that will make our things easy. Yes, it will make you easy until and unless you use it properly. Okay, that's why at the earlier stage, please don't use AI. Use AI for debugging. Give the log, give the error message to the AI with your code. It will give back you the result that you have made a mistake over here. It can be done in a better way like this so that you will not face this issue. Something like that. So first write your code by your own hands. First make your hands dirty. Okay, then go for AI for the solution. If you just go to AI and generate a code, you will be landing in different codes finally. Um, you may get a different result as you never expected. Okay, because of the prompt which you are giving is not so correct, right? That's why. But one more thing is there. Today, what are all the AI features or the ChatGPT, Gemini, and whatever the things we are using today? They are not giving the verification codes correctly. They will put some other extra stuff over there and make you confused. Even if you generate a simple verification test bench, class-based test bench, try to generate, you will come to know, even if you know system Verilog, even if you know UVM, you can't debug it properly. Again, you need to go back to AI and ask why have used this. So that is the stage AIs are today for verification. Yes, you can use it if you have a pro account, if you have a very good paid feature there. But using AI for coding at the earliest stage is dangerous in VLSI. First, understand the complete scenario what you are trying to do. Try manually. If it doesn't work for you, if you need a particular thing to be coded, then use AI. Especially debugging, you can learn easily through AI. And also, I will show you how exactly AI can be used. And ultimately, we need to incorporate AI in our verification strategies that we do in our regular trainings. I will come there. Then engineering environment. So you need to learn tools, right? Finally, every VLSI industry work on Linux platform. You need to well verse with Linux commands. Okay, how the Linux terminal will be, what exactly the command do, how to trace some file, how to grep something like that. You need to understand the Linux commands and the line utilities. Then verification tools like Vesta Simulator, VCS, Cadence Xcelium. Even freshers can start with a simple online available tool called EDA Playground. Okay, answer me. How many of you know EDA Playground exists, and you start using that? How many of you know EDA Playground? Can you say yes in the chat if you know EDA Playground? I know. Yes. Don't know. Yes, I know. Yes. See, if you want some coding, if you want to start some Verilog code, you no need of Vivado tool, you no need of Quartus tool, you no need of a Synopsys tool, Cadence tool. Okay, you can write a very simple code in EDA Playground. You can write a test bench as well. You can simulate it then and there itself. It will give you the same log as your Synopsys VCS gives. Yes, iCaras gives, and also your Aldec Rivera Pro gives. It has some free simulators available there. Okay, you will understand if I put something like this, what exactly the tool will respond. You will understand it easily. You can look at the waveforms as well, right? So start using EDA Playground. EDA Playground is a very good tool to write some code in a design part, and also you can write a code in a test bench, and you can easily get used to it. Okay, so EDA Playground is one thing which can usually everyone can start with. Then also you can do some complex projects there. Even it will support coverage, UVM, system verilog, everything. Okay. So then that is what the next thing is. We need to understand tools exactly. How exactly tools matter for a fresher? That is the another question. Many of the freshers have misconception that if I know Cadence tool, if I know Synopsys tool, if I know some other Siemens tool, it's easy to get into industry. No, that is a misconception. Okay, if you are guiding someone that hey, please learn tools to get into industry, that may work in very few cases. In many cases, only your knowledge matters. Okay, so please try to use some free available tools, gain knowledge. If you are able to write a code comfortably, then tool matters. You can learn a tool in a single day. You can spend some 2-3 days and understand what is the debugging flow, how exactly you can trace a waveform, okay, how you can trace a code, that you can learn easily. But tool itself is a biggest challenge for me. I am getting not getting into industry is a misconception. Okay, nowadays tools are available even in your colleges. If you are still student, spend some time in college and get used to it. Just try to understand what exactly tool will give you. Okay, then you can easily adapt in a industry to any tool within 1 week at least. Okay, and then you can also install GVim in your system. You can install VS Code. Okay, you can install even some Questa sim simulators are available. You can install and you can try at your own system. You no need of any complex advanced tools at the earlier stage. That is what my suggestion is. If you have that in mind, please don't go with that. Tools are at the last. Okay, you can start improving your skills first. Then what exactly needed after tools? The last one which I suggest you is scripting. You need to understand Perl, Python, TCL scripting. These are required for automation. If you want to automate some runs, if you want to run some 10 test cases at a time, if you want to run a regression, and if you want to build a system which will give you the exact uh, uh, how you read the log in the similar way, your system will give you what exactly happening in the simulation in a structured way. Okay, then scripts are needed. Script will improve your productivity through automation. Okay, scripting is required to automate some tasks. This scripting is very much useful. Okay, once you get into industry, if you know scripting, you can easily play with your project. You can easily handle complex things. You can easily automate many things over there, and you will get the quick results. So for regression, to build some standard flow for the run industry use scripting. If you know Python, if you know Perl, or if you know TCL and other scripting languages, it is very good. But before that, Verilog, System Verilog, UVM is much important. You need to start from there. After that, projects, then tools, then it will be scripting. Okay. If you know System Verilog, you can easily learn Python at the end. But what people do, first they will learn Python, then they will think Python is very much required everywhere. They will get multiple opportunities, chances. They will concentrate on Python. You will be land up as a Python engineer. You will be not being a VLSI engineer, right? So scripting will be at the last, but greatly it will help you in things in industry. So these are finally the pillars in VLSI design verification. Remember, not only 4, there are 8 now. Verilog, System Verilog, UVM, then protocols, then debugging, projects, tools, and scripting is required. Okay. So let's move on. What exactly the roadmap? What exactly the roadmap anyone has to follow, and even we follow in Logic Cells Technologies. Okay, so being an electronics engineer, okay, being an electronics student, let's say, what exactly the very first thing you need to do is learn digital electronics. Learn digital electronics starting from gates. Many students I see every day, they know digital electronics. Every engineer who completes degree know digital electronics, but they will fail to express a very simple digital electronic concept. Why? Because suppose if you take a simple multiplexer or any gate or any adder or any some computing device, where exactly that will be fit? Where you will be using a multiplexer? Where encoding is required? Why there is a concept of something like bit, byte? Okay, you need to understand, right? In a system where exactly that bit matters. When I will be declaring an 8-bit data, why a processor will be called as 32-bit processor? It will handle 32 bit at a time. That's why it is called as 32 bits, right? That and all you need to learn in digital electronics. Not only gates, not the truth table, not the gate level circuit you will write. Gate level circuits and all required to understand how the connections will be, how we will be getting the final result by putting all those at once. But digital electronics is something beyond that. You need to understand where exactly flip-flop is used. How exactly I can build a complex sequential circuit using flip-flop. What exactly FSM mean? What are all the states mean? Where exactly in industry we will be using FSM? You need to upgrade your knowledge in that way. If you know multiplexer, today go back and check where exactly this multiplexer feature will be used in a complex project. You will get a first answer as it is a data selector. If there are multiple data as input, if you want to select only one, you need select lines, and these are all the multiple things channels you have, and finally you will get only one out of them. You will never learn this in your digital electronics course. That is the problem. You need to think of whatever you learn in your academics one step ahead. Think where exactly that will be useful. Then you will learn the actual things required for industry. Then build some Verilog codes. That is what the design also you need to understand to be a verification engineer. So Verilog is also at most important for us. Then master in system Verilog and UVM. This is mandatory stage. This fourth stage is very, very important. You need to spend more time in understanding system Verilog and UVM, and then protocols. Once you gain a knowledge of system Verilog test bench and how you can write a UVM test bench for that, then you will learn protocols and industry projects. Industry project mean combining 2 to 3 protocols, you can make a complete system. Okay, that is exactly how industry works. It will not, your projects will not rely on a single protocol. Correct? So that's why you need an understanding of industry level protocol. You need to understand how exactly in industry these protocols will be used in a system level. Then you need to prepare for the mock interviews, okay? And then you need to prepare your resume in a proper format, and you need to optimize your LinkedIn. Everyone, please start optimizing your LinkedIn. Post some meaningful technical thoughts. You should be active in LinkedIn so that your profile will be visible to the network of the similar grade engineers, okay? And also for the HRs who are looking for the candidates, and you will get, if you are following some company page, then you will get a immediate notification that they are hiring. So this is how the process works in LinkedIn. That's why you should be active. If you are not so active, you just have an account in LinkedIn, that not works well. Okay, so please be active in LinkedIn, and while preparing the resume, please prepare your resume for the particular job role you are applying for. See what happens generally. Freshers do this mistake. They will keep one resume. They will be keep on applying for the multiple roles or in multiple companies with the same resume. Okay. If you remember, if some company called Intel, if they are hiring a design verification engineers, their job roles and descriptions are different from the other company, let's say AMD, which is hiring for the same position. Correct? Have you observed it? Have you gone through the job descriptions what they post? If anyone observed it in the career portals or in any job openings, can you please comment? See, let's say Intel is hiring for a design verification role, and AMD is hiring for a design verification role. Will they hire with same skill sets and same things? No. So they may need some APB, AXI expertise, AMBA protocols expertise. Some company, suppose if you go to ARM, they will surely expect AMBA protocols. Okay, you need to know ARM architecture. Then you can get into ARM. If you want to be an Intel, then they will be having certain requirements. You should know pre-silicon, post-silicon validations, and also you need some processor basics and all. If you want to be in a Micron, then they may need memory-related things. So while applying for an interview, please go through the job description. Please spend some 10-15 minutes on your resume. Modify that resume as per the job description requires. You should not simply put their requirements as your skills, but you need to align your skills to the job description, what it has. Then there will be high chances of shortlisting into interview first. If you get an interview, then only you can crack. If you don't get a chance for that interview, you can't get into a company, right? So your resume shows what exactly you are, right? And also you need to make that resume align with their requirement. Then only there is a chance to get into interview. Otherwise, you will be keep on applying for the roles. You say, sir, I am not getting the calls at all. I am applying 10 to 20 jobs daily. I am not getting call. Why? Because you will do some embedded project in your final year. You will put that as a major project I did, and you are applying for a VLSI role. How come they consider your embedded knowledge or any other knowledge if you done a, let's say, if you are doing some project which is in analog domain, analog schematic and layout, if you are putting that project and if you are applying for a verification role, why should that company choose your resume and they will give you verification chance being an analog design engineer, right? So that will not work in that manner. If you know the things related to job description, then put that in your resume and apply in a proper manner. That is what we do at the end of your course. Usually we prepare you for resume building, mock interviews, optimizing LinkedIn. Then only you will be getting chance into be a ready engineer for industry, right? That is what the important stage actually in any anyone who is looking for the uh, job. So majorly many freshers will fail there. They will put a simple project, some common projects, and they will apply for all the roles. Then see here, what exactly we do in Logic Cells Technologies in our upskilling programs or in trainings. At least we will cover these 6 projects for a 6 months trained guy. We need to start with a memory verification. A very simple memory called RAM need to be verified aggressively with different test cases. You need to know the memory architecture first if you are doing a memory verification. Then you need to develop a test bench. You need to design it and then develop a test bench. Then you need to complete the verification using Verilog itself. Write a simple Verilog code based on tasks. Complete the verification activity, what we can do better in Verilog. Then the same project memory verification need to be taken. Write a system Verilog test bench code, verify it using system Verilog test bench. You will understand what I did in Verilog test bench, how I ported that into system Verilog test bench. Then you can write it in the UVM. Now you will be doing a single project. Okay, you will be doing one project in 3 environments. You will write a Verilog test bench, you will write a system Verilog test bench, you will also write a UVM test bench. That give you a complete idea of how exactly memory can be verified and why UVM is much preferred over system Verilog. This is where you will stand out. That is what we follow. Okay, this is a very simple project. Just read, write, checking in a memory. But you will be having dealing with both Verilog, system Verilog, understanding, and a UVM project. Then you need to do FIFO verification. You can choose FIFO or any router or any other bit different one compared to memory. You can do synchronous FIFO verification, asynchronous FIFO verification, build system Verilog and UVM test benches. There are some corner cases to be verified here in asynchronous FIFO especially. You need to handle CDC as well. So you will understand all those different concepts compared to memory in a FIFO verification. Remember, what we follow is if you understand a memory verification, the same kind of test bench can be ported into FIFO verification with some small modifications. And FIFO has some particular features called full condition, empty condition, almost full condition, overflow. These are all will be verified as corner cases in FIFO. And also you need to understand the depth of the FIFO, right? So all these matters in FIFO verification. This can be your good entry level project. Then you need to step into a protocol. Okay, I said your system need a protocol to communicate effectively, correct? So a very simple protocol to start with is APB. Everyone should start with understanding APB protocol. You can connect that with a memory again. So this is not an individual project what we are doing here. Do the memory verification, convert that into a FIFO verification test bench, then you can build an APB ecosystem on the memory what you did. Okay, here you are seeing it as 3 projects, but actually these 3 having one step-by-step improvement in your verification strategies. Okay, here you will learn only memory verification read writes. Here you will understand how actually your memory will be behaving as a FIFO and which are all the different CDC aspects you will see in asynchronous FIFO. Then you will be building an APB ecosystem on the memory. This is a strategic flow of how actually one can do projects. You should not do a memory verification, directly jump on DDR and PCI, not like that. You should go step by step. Then you will understand how complexity increases in the system you will adapt easily in industry as well. Then other protocol verifications, like after doing APB or AHB or AXI, you can start verifying some serial protocols. Okay, let's say UART, SPI, even AXI, and also the system which will be having master and slave functionality. You can develop a VIP there. So that is where you will understand how a complex functionality will be verified. Okay, then we can also do regression here. Okay, multiple test cases will be regressed and check the functionality or verifying the protocol behavior. Then a very important and high-end project to impress the companies is DDR controller and PCI. You can also include Ethernet over here, and also you can have an USB verification here. But if you put a DDR as a skill, if you put a PCI as a skill, you will stand out as an engineer who knows to the level of 1 to 2 years of experienced guy in industry. Okay, many projects will be having a DDR in it, or you may get into a memory related verification companies as well, like some companies work on memories especially. So this DDR is very much useful. And in any complex projects, if you go, PCI will be there. So PCI layer design, test bench development, debugging, and understanding of PCI different layers is very, very important in today's trend. Okay, so DDR and PCI are the very big projects we will cover at the end of the course. This is what we do generally. We will start with a simple memory and we will connect that to FIFO and APB. Then we will build PCI, DDR, and these protocols. Then after doing these projects, what exactly the stage you will be in? After doing these, you will be industry ready. Okay, the very early stage you will be in a curious stage and exploring stage. Oh, I need to learn Verilog, system Verilog, like that. Many of you are in this stage today. After learning system Verilog and UVM, remember, after learning UVM also, you will be in learning and building stage. You are not industry ready. Remember this. If you know UVM, system Verilog, I am ready to attend interview. No, you are still in the learning and building stage. Once you put that effort of these skills into a project, then you will come to this stage. You are applying your knowledge and preparing the verification strategies. Then you will understand how exactly the problem solving works through the projects. You will understand debugging. Okay, then you can prepare your resume and you can attend mock interviews, and then you will be ready for the industry. So once you are ready, it means you know Verilog, system Verilog, UVM as basics. Then you know some protocols, and then you know tools as well, and you know some automation skills as well, and scripting as well. That is how a confident DB engineer will go for an interview. Okay, that is what we call it as interview ready trained fresher. To call you as a trained fresher, you should be in a stage where you have already built some projects and worked on debugging as well, and I have used scripting. I gone through 6 months training in an industry level training, and now I will be ready for the interview. So 6 months trained fresher will be getting more opportunities. So what career support we do in our trainings, after your completion of all the skills, your resume will be ready. You can start attending interviews if you are very confident after completing one project itself. Okay, if more opportunities comes, then we will be guiding you how actually you can build your LinkedIn profile that attracts the recruiters actually. Then career guidance, one-to-one mentoring will be done. If you have any things to be discussed with a mentor, you can discuss at any time, and you can attend multiple mock interviews. So that will give you the confidence that how actually you can answer in the interview. Okay, directly you should not go to the interviews. Actually, you should go on through multiple mock interviews with multiple interviewers. Then only you will understand your level. Then job updates, you will be informed with the different fresher openings. We have some referrals, and we will assist you for the placement till end of your till you get a job in a company. This is what the 5-step process we follow. This is a career support beyond the classroom. What we do, we will not stop you after the teaching. We will keep on posting the fresher openings, and we will ask you to apply there. We will prepare your resume. Then we will also provide some referrals if you are really fit to that particular role. Okay, so your referrals works very well in industry. So that is what the career roadmap is, and that is how you need to start, and that is where you will stand out as a trained fresher after some 5 to 6 months of training. Okay, so the thing is, we are starting our new batch for this design verification from July 20, that is tomorrow. Okay, we are starting a 6 months and 3 months batches here. If you want to be if you are a very fast learner, if you are available offline, you can take a 1 month fast track course as well. You can spend full day time in our company, and you can build your projects there. In first week or in 10 days, you can finish Verilog and you can start system Verilog, and then you will be going through the protocols Okay, and parallel you can learn system Verilog as well and UVM as well along with the projects. Why? Because if you want to be industry ready in 1 month, it's very difficult. You need to spend much time, okay, on building the projects itself, not learning the syntax, not directly just going with the syntax. Okay, not no more just preparing for the theory. You need to completely work on the project. That is what your 1 month fast track is. If you are a good fast learner, you can do that, or you can take a 3 months course that makes you industry ready. It is best for students who are in 6th semester or in 7th semester like that. Or if you are well equipped with your time, if you have a 6 months duration time, completely you will be ready with the design verification. Okay, that will be an advanced design verification course. You can also take that. Okay, so that is what the complete journey of a verification engineer is in the early stage. Okay, you can start building your skills as we discussed here, and really that will help you to get into an industry. Okay, if you have any questions, please ask me. I will give you the feedback form that leads to that through that you can get a certificate as well. Okay, I will just post it in the chat box. You can just fill that as a feedback. Okay, we will issue a certificate of this webinar through that. Right now, let me know if you have any questions through the chat box, or if you can unmute yourself and speak out. Please ask. Is it better to pursue a master degree before entering the VLSI industry? Is a question here. Okay, let's try to understand what exactly happens if you do a mastering. Okay, if you do masters. See, generally what happens, people complete engineering, okay, and they will be looking for the job, right? So for them, it is a 4 years course. Okay, they will learn basics and they will learn all the necessity requirements. Let's say digital electronics, Verilog, and a bit of CMOS VLSI you will learn in your undergraduation. If you pursue master's degree, okay, let's say in VLSI, your VLSI masters will be having, it may have some part of let's say digital design. You will learn Verilog advanced there. You may learn system Verilog as well. Okay, again you will not learn UVM. As I know, your master's syllabus, what the universities has, they will not give you an opportunity to learn UVM if you want to be a VLSI design verification engineer. So other than spending 2 years as a master degree, in a master degree, you can spend for learning these advanced concepts, and you can try out a job in an industry. Master with a master certificate or a master degree, you will give a confidence that 2 more years you spend on learning VLSI, but that will not give you much edge. It may give you an advantage when you are trying to get job through the colleges. If you get in a tier 1 college, if you are getting a master's degree from an IIT, go. If you want to pursue masters in at least in NIT or triple ITs, you can go. But if you are doing a master's again in a type 2 and type 3 colleges, they may not having good placements in VLSI. Again, you will end up in as a fresher, and you will start looking for the opportunities outside. That should not happen if you are spending 2 more years. My suggestion is complete your degree, spend at least 6 months to 1 year in learning these things required for industry. Then you can get into an industry directly. Okay, that is a straightforward way. Or if you pursue masters, please make sure that you will be doing in IIT or NITs or triple ITs at least, or a top tier colleges which will provide you placements. Please check their placements and ask them directly. I need a VLSI job. I need embedded job. Will you provide after completing my masters? Okay, why? Because you will be doing masters in a particular domain. You will be doing masters in microelectronics or in VLSI or in digital electronics. Then you should be land up in a particular job role, right? So please make sure that that will give you an immediate placement after your degree. Then only you can do masters. Otherwise, again, it will be a waste of 2 years. Think it is of 2 years. Okay. Anyone else has any questions to ask? Can we get this PPT? Yes, I can forward you. Please ping me in WhatsApp. You can ping me through this number. Okay. We need to discuss about the fees, right? See, we have 3 courses here. Let's talk about 3 month and 6 months courses here. Okay. Why? Because many of you want to be in an industry with a proper guidance mean at least you need to spend 3 months. And if you are a good self learner, after 3 months, I will guide you how you can build your advanced concepts. Okay. You can take 3 months course and you can spend much time on understanding through the spec and learn advanced concepts as well. So every time PCIe or DDR knowledge is not required, you can also learn theory of that, and you can get some simple coding with respect to that, and you can get through. But if you want to be in a strategic process with a placement assistance and complete guidance throughout the journey, you need 6 months time. Okay, advanced 6 months course you need, and 1 month fast track is for who, which they can easily get through the design verification things, and they will complete learning system Verilog UVM, and they will easily adapt into project in a quicker manner. They can spend complete 1 month of duration, means morning to evening in our company. That will be just like an internship working on a project. So they will quickly learn as well, but it is only offline. So the fast track program what I am showing here is an offline one, and you can take 3 months and 6 months in an online mode as well. Okay, every day we will be having 1 to 2 hour sessions in the evening generally, and you can take 3 months 6 months course. So if you want a fast track, please ping me personally. I will guide you how actually you can do it, and physically in a office. Okay. And for a 3 months course, okay, 3 months online course, we will be charging 15,000 if it is online, and even for a 6 months course, we will be charging 35,000. Many other institutes charge in lakhs together. Okay, it's up to you if you choose them. But my suggestion is, you need skills, you need a proper guidance, you need each and every code to be understand. You need a particular mentor who can guide you as along with your this 6 months or 1 year journey. So we will provide you, we will assure you. Okay, this 3 months course, as I said, best for students of engineering and those who completed degree just now. And for the one who already completed your engineering and you are looking for the job, and you need a particular exact skill what which will leads to an industry, you need at least 6 months. Okay, we can also fast track this and complete it in 4 5 months, and you can spend some more time on mock interviews and all. But 6 months is a very good advanced one, so best for complete career transformation. Okay, or you can try with 3 months, sir. I will then shift to the next 3 months advanced one. That is also possible. You can enroll to the 3 months course. It has a 15,000 as a fees, and you can take the advanced course then again, and you can pay the remaining fees after 3 months. That is also well and good. Okay, we will be keeping 35,000 as an advanced course fee. Okay, if you need more things to be discussed, please ping me on this number. You can call me to this number. If someone answers, ask. I need to talk to a mentor. Okay, you will be guided in a proper manner so that you can choose it, whichever the course you need. Right, that is what we follow. We will commit you for the knowledge, okay, that leads to placement at the end of your course. Okay, there is nothing like a placement assurance 100% placement. Many students will ask, sir, I will pay 35,000 for your 6 months, will you place me? No, it will not happen like that. If you put your effort, okay, you are paying for the skill what you are going to get, and you will learn the things as industry requires. Then you ask me after preparing everything from the scratch to advanced, sir, why I am not placed. That is how you can. But at the time of uh, enrollment, if you ask me, sir, I will get a placement if I take 6 months course, I say, please complete the course, then ask this. So what is the difference between Verilog and System Verilog? Okay, so I think Purna, I think you have joined a bit late. We discussed this at the starting. See, the basic difference between Verilog and System Verilog is that Verilog is suitable for hardware design. Okay, it means we call it as a hardware descriptive language. Okay, hardware description language. So whatever the code you are going to learn, write, will be for the design, some hardware. But System Verilog is having more advanced features over Verilog. Means it has OOP switches, class-based test bench we will write. We will be using System Verilog for test bench writing. We will be using for especially for verification. Okay, it supports Verilog, and then it will also has OOP switches that will give you an edge over Verilog for verification aspects. So that is what the basic difference between Verilog and System Verilog. There are many other things like it will support randomization, it will support assertions, it will support coverage. You can verify the functionality in a better manner in System Verilog compared to Verilog. Okay, there is a question here. Where is the institute? Okay, just Google it. Logic Cells Technology. You search for Logic Cells Technologies. It is based in Bangalore, in Nagarbavi. You can find the address easily. Okay, you can easily come to our institute, and also you can talk to the mentor, talk to me, and get a free career guidance. Then you can decide what exactly the path you need to choose for your better career. Okay. So to learn VLSI design easy. See, everything is easy until we go through that process, right? See, in a abstract way, in a top level, we can say it is easy, it is difficult. Okay, every engineer will start by thinking like this: will it be easy? Is it difficult? Can I do it? If someone is doing it already, why can't you do it? That is what I say. If someone is doing it already, if you follow the same structured way, everyone can do it. But it is not like easy and difficult. compared to software engineer roles, VLSI roles are a bit tricky. You need more skills compared to software roles. Why? Because there are enormous tools and the things available for the mm, software engineers today. There are many AI tools that will give you a quick response. But in VLSI, you need more effort in bringing your knowledge, right? That's why it may feel bit difficult compared to software roles, but everyone can do it. It is an let's say it is an easy process as well. If I want to do only internship, can you provide? Avinash Singh, yes, please you can contact us. Let's see what exactly you pursue, and let's think of it. You can do internship with us. Okay. Yeah. Do you have any other questions? Certificate. Where can I receive after the feedback submission? I have provided the link. Please submit there. We will send you the certificate through an email. Okay. You will receive an email after this webinar. So there you will be. You can download your certificate. Okay. And if you have any questions, please let me know. Let's finish it off. It's already 12:36. Do you guys have any more questions to discuss? Any question which I have missed here? Okay, what is the difference between design and design verification? Sanguti asked. The difference between design and a design verification is in a VLSI design role, it's like a RTR design role or any other ASIC role or FPGA designer role, you will be writing a Verilog code to satisfy the functionality of the design. Okay, but in a verification role, design verification role, you will be developing a test bench. Okay, and you will be verifying that design whether it is correct. Design verification, you can relate it as verifying the design which is already built. Design stage mean you will be writing the code for designing it itself. That is VLSI design. VLSI design verification is writing a test bench to validate or verify that design. What are all the skills required for a fresher for any internship? Yes, for a VLSI internship, please be prepared with Verilog, digital electronics, computer architecture fully, and be ready to learn system Verilog and UVM. You should learn simple codes and what are all the constructs we have in system Verilog and UVM, and you can apply for the internships in any product companies through that. You may have more chances to get into. Okay, but again, that depends on the role of the internship. If it is a design or design verification internship, then you need Verilog, system Verilog, digital electronics, computer architecture, these things. If it is an analog internship, analog designer internship, then you need schematic, you need layout, you need how actually the transistor level circuits are, what is the libraries we are going to use there. Okay, we call it as so those things you need in an analog domain. And also analog mixed signal is another domain actually we have in industry. There you need to understand how analog and also digital things works together. AMS, we call it as AMS. Okay, do you have any other questions? Is this the display number to message or for PPT? Yes, you can message there. There is an WhatsApp number, you can ping in WhatsApp. Can tell about physical design. Okay, so if you want to be a physical design engineer, okay, you need to understand how actually the things are going to be placed on the IC, means on the silicon. You need to understand placement, you need to understand routing, clocking strategies, okay, and timing aspects. You need to understand setup time, hold time, and metastability. And physical design engineer mostly working on these things. Okay, place and route are the many floor planning, how you will be planning the complete chip. So all these are the physical design aspects that will be called as backend. Okay, and you need to understand how the schematic will be after the netlist is given. Okay, so that is what the physical design role is. Compared to physical design role, if you know coding aspects, you can be a design verification engineer. If you want very less coding, more tool effort, it will be also having some scripting and Verilog needed in the physical design, but that is more let's say tool dependent. You need more knowledge on the physical parameters of the chip. You need to work on the size, delays, timing aspects, um, everything related to the timing and the area. Any other questions? PCB designing engineer role. See, PCB design, yes, it is one of the role, but it has very less opportunities, I guess. So PCB design will be not a VLSI role, we can say. Okay, in here we'll be majorly concentrating on IC design and verification of that IC and how actually things work before the fabrication is right. But PCB design is a different aspect where you will be working on the PCB side and how actually the PCB is going to be designed and components are going to be connected and how actually it is placed. Okay, so that is a different role actually. Okay, many of you are I think aware of the roles in VLSI, and there are some open source EDA tools available. You can explore that. Even ICARS Verilog GTK Wave, someone has mentioned here. It's good. Okay. Difference between joining MTech and VLSI and doing any course in an institute, which is better? I will suggest do a course. Okay. And remember, already I told you, if you are getting an MTech in a very good college which has placements, then you can go for placements. Sorry, MTech. Why? Because after doing an MTech, again joining an institute for the skill which is required for an industry is not so recommended. Why? Because already you spent 2 years there, right? At least if you get an opportunity through your college placement, then you go for MTech directly. Okay, then you may get some advantage in the industry at the time of hiring also. If someone asking MTech directly, you can apply there. But just wasting 2 years in some other type 2, type 3 colleges which will not support you for VLSI placements is again a waste, right? So better you can choose a course. You can spend 6 months or up to 8 months or 1 year, even if you are if you want to spend, and then you can get into an industry. That works better. Or if you have a good uh, gate score, you will get a college and it will be providing you the placement, then it is good to do MTech. Yeah, Avinash is suggesting logic cells technologies. Okay. Do you have any other questions, guys? Shall we wind up here? Everyone fill the Google form for the feedback so that we can issue the certificates through email. Okay. What if I did course and do for internship for 6 months and then joining MTech in a good college like IITs? Yeah, you can do. You can do course. Then also you can do internship if you get an internship in a very good company. That itself, let's say if you are doing an internship in a very good company, they will absorb you as a full-time employee. Many times product companies do like that. They don't want to invest in freshers and land up in training them again, so they will provide internships. Even you will get a stipend during the internship, and through internship you will be get absorbed as a full-time employee. If you are getting an internship in any company which will work on design verification, physical design, DFT or whatever, you can grab it. Later if you want to switch into a particular domain in industry, there are chances to switch, but getting an internship in a product company is very good. Okay, other than choosing a 6 months course in an institute. Okay, that will give you a real experience. Even if it is not stipend based, you can choose internship, but you should check whether the company will work on real industry projects. Then only you will learn the industry perspective there. Otherwise again it becomes just like a course and you will understand protocols and you will work on the protocols. Then again no need to go to MTech after completing the course and internship. You can directly search for jobs. I think I answered many of your questions. If you have any question still in your mind, if you're not opening up here, you can ping me on that number, okay, and you can get clarified. Okay, we can stop here. We are stopping here. I think you enjoyed this webinar. You got some basic knowledge of the requirement in the industry, right? Okay, all the best. Timings of online classes, it will be generally in the evening after 6 p.m. Even we are planning for weekend batches. If you are working in another industry and if you want to switch, we'll be having weekend sessions, so you can take weekend as well. But generally these 6 months and 3 months online courses will be in the evening. Okay guys, thank you everyone. Thanks for your response, and I hope this webinar is useful and you get some knowledge and you will adopt in your learning. Okay, thank you. All the best for your VLSI career. If you need more assistance, please ping us. Let's discuss this. Thank you very much. Bye.